Let's talk about average rate of change for a function. Sometimes a function goes up, it goes down, it goes quick, it goes slow. We'd like to take the average of that over any given interval. Okay, so first let's define average rate of change. The average rate of change over an interval, and I'm going to cheat right here and just say that's what goes in that blank, okay, over an interval of a function describes how quickly the function changes. It's defined as the change in y values divided by the change in x values, okay? So formally we say that it is f of b minus f of a over b minus a, okay? Your function values are your y's, and your b's and a's are your x's, right? In Algebra 1, you called this slope. You said the change in y over the change in x, or y2 minus y1 over x2 minus x1. This is just a fancy way of writing y2 minus y1 over x2 minus x1, okay? So we're going to find some average rates of change. We're going to find the rate of change from -2 to 3. So -2 is right here. The function value there is -1. And 3, 1, 2, 3 is right here, and the function value there is 4. So you can start at either one of these points. I typically start with the furthest to the right. You do not have to, but if you use whatever point you take your y value from, you have to start your x value there as well. All right, so I'm going to say that the y values, well, I'll write this one out first. So I would say f of 3 minus f of -2 over 3 minus -2, okay? And f of 3 is 4, and f of -2 is -1, and that is all over 3 minus -2. All right, minus a negative is a plus, so this ends up being 5 over 5, which is 1. So the average rate of change from -2 to 3 is 1. Okay, we're going to do this over and over again. Let's look at C. We'll skip B for now. All right, if I'm going from 0 to 5, let me change color here. So now I'm not doing these anymore. I'm going from 0 to 5. All right, I would say that f of 5 is 2 minus f of 0, which is 1, over 5 minus 0. So I get 2 minus 1, which is 1, and 5 minus 0 is 5. So the average rate of change for part C is 1/5. So if I said what is changing faster, A or C, you would say, well, A is changing faster because 1 is bigger than 1/5. Okay, so let's answer some function questions. Is the function increasing or decreasing over the interval 2, 4? So let's look at 2, 4. It starts here. Oops. Starts here and goes to there. All right, so from left to right it is going down, so we will say that it is decreasing. Is the function increasing or decreasing over the interval where x is between 4 and 6? Well, x is between 4 and 6 from here to here, so that is going up from left to right, so we will say that that one is increasing. The absolute maximum value of f. This is a good question because there are a few. Do you see how this height is the same as this height, which is the same as this height? Okay. If I'm asking for the absolute maximum value, remember I'm asking for the y value, which is the same for all three of those, and that is 1. Okay. The absolute minimum value is this and this and this. There's not one absolute minimum because all three of them have the same y value. So the absolute minimum value of f of x is -1. Okay, the average rate of change over these intervals from 1 to 4, I'm going to erase this because there's a lot of noise on this graph. From 1 to 4, so 1 is right here and 4 is right here. All right, I'm going to do my average rate of change formula. I'm going to subtract the y values. So at 4, the y value is -1. Oops. negative 1 minus, at 1 the y value is 0, over the x values, so 4 minus 1. Okay, this is f of b minus f of a over b minus a, where 1 is my a and 4 is my b. If I clean this up, I get negative 1 over 3. So my average rate of change over that first interval is negative 1/3, which means that it's decreasing from here to here. And if I were to connect these 2 points with a line, the slope of that line would be negative 1/3. Okay. What's the average rate of change from 4 to 8? Let's do it again. So at 4, my function is right here, and at 8, my function is here. You might be able to see visually what the average rate of change is, but let's do it mathematically. All right, the function value at 8 is negative 1. So I'm going to say negative 1 minus negative 1 over 8 minus 4. All right, f of b minus f of a over b minus a. And negative 1 minus a negative 1 is 0. 8 minus 4 is 4. So this ends up being 0. And that makes sense. Do you see how from the left side to the right side, that has changed not at all. The slope of this line is 0. Okay. And then finally, we're finding the zeros of this function. So the zeros, oh, there's a lot of them. Every time, here, let's make those dots bigger. Every time I cross the x-axis. So here, 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 and here. See that dot at 11 is closed, so I include it as a 0. If that dot at 11 was open, then I would not include it as a 0. All right, so my zeros are the x values of those locations. What a mess here. So I would say x is 1, 3, 5, 7, 9, and 11. All those x-intercepts. Okay, let's do a few more problems. Lyme disease is a bacterial infection transmitted to humans by ticks. When an infected tick bites a human, the probability of transmission is a function of the time since the tick attached itself to the skin. All right, during the first 24 hours, the probability is 0, so you're not going to get infected in the first day. During the next 3 24-hour periods, the rate of change in the probability is always positive, but is much greater for the middle period than the other 2 periods. All right, which means that here, if the tick's on you for 1 day, you're not going to get infected. The probability of you getting infected is 0. On the second day, the probability goes up. If the tick is still on you for the 3rd day, then that probability goes up a lot. It increases rapidly. All right. And then on the 4th day, the probability still is going up, but it lessens a little bit. And then if the tick is still attached to you on this 5th day, probability is basically 100% you're going to get Lyme disease if it's on you for 5 days. Okay, so this is the function for the probability of transmission. Okay, true or false, there's no interval over which the function is decreasing. That is true. Okay, the longer the tick's on you, the probability of you getting infected just keeps going up and up and up. Over which interval is the average rate of change the greatest? That's the same as saying, where is this graph rising the fastest? Where is it the steepest? And it is on this interval right here. Okay, so we're going to say that that interval starts at 48 hours and it ends at 72 hours. That's the greatest risk time. That's when your probability increases the most. Okay, so the average rate of change on that interval is the function value at 72, which we're going to say is about 75 based on an estimate here, minus the function value at 48, which we'll say is 10, over 72 minus 48. All right, 75 minus 10 is 65. Okay, and 72 minus 48, what is that in my head? I don't know. 72 minus 48 is 24. So you could write that as a fraction, or you could write it as a decimal and say 65 divided by 24 is about 2.7. Okay. Let's find the average rate of change over the interval 72 to 120. So at 72, my function value is about 75, and at 120, my function value, I'm just going to say, is about 100. So I'm going to say 100 minus 75 over 120 minus 72. 100 minus 75 is 25. 120 minus 72 is 48. You can keep it as a fraction, but when we're talking about these real-world scenarios, sometimes it's helpful to look at them as decimals. So I'm going to say 25 divided by 48, and I get 0.52. All right. So between 48 and 72 hours, your probability of getting infected is rising very fast. It's rising at 2.7. All right. And then after that, the probability is still rising, but it's not rising as fast. Between 72 and 120 hours, so the last, or day 4 and day 5, you're rising at 0.52. Okay. Now, you can find average rate of change even if you're not looking. So if I am looking at this function right here, f of x, over this interval, -2, 1, okay, I can still calculate f of b minus f of a. I'm just going to write it out. So I'm going to say f of 1 minus f of -2 all over 1 minus -2. Now I'm going to use this function instead of a graph to give me my function values. So f of 1, if I put 1 in, I'm going to calculate these up here. F of 1, if I put 1 into my function, is 2 times 1 cubed plus 1, so 2 plus 1, which is 3, minus f of -2, which is 2 times -2 cubed plus -2. So I have -8 times 2, which is -16, minus 2, so this is minus -18, all over 1 minus -2, which is 3. So 3 minus -18 is 21 over 3. 21 over 3 is 7. So the average rate of change of this function from from -2 to 1 is 7. That's the answer. You can also do this calculation if you have a table. So you can say, I want to find the average rate of change over -6, 5. Well, I need f of 5 minus f of -6 over 5 minus -6. All right. F of 5 in the table is -1 minus f of -6, which is 5. All right, over 5 minus -6. So I get -6 over 11. So my average rate of change is negative, it's going down, and the value which it's going down is -6 over 11.